Okay, so let's continue to look at some problems. The next one is to verify determinant A equals determinant B plus determinant C. I think this is a purely algebraic problem. Okay, so you can verify by yourself. Basically, just write it down, and then you will figure out that those two are gonna be the same thing. Okay, so I'm gonna skip this one, and then move on to problem 5. Use the Cramer rule to compute the solutions of this system. So this is a system, so 5, 7, 2, 4, x1, x2 equals 3, 1, right? So if we write that into these matrix form, right? Okay. Now, what we need to do is, so the Cramer rule says that the x1 equals the determinant of a1 over the determinant of a. x2 equals the determinant of a2 over the determinant of a. A is given here, a1, which is use b to replace the first column, so it's a 3, 1, 7, 4. A2 is going to be used this column b to replace the second column, so it's 5, 2, 3, 1. As corresponding to the determinant of a, it's 20 minus 14, so it's a 6. Determinant of a1 is going to be 12 minus 7, so it's 5. Determinant of a2, so it's 5 minus 6, right? So it's negative 1. So easily you can derive that this is equals to 5 over 6. This is negative 1 over 6. Okay, so that's it. Simple. 2. Which value has a unique solution? Describe that. To make sure that it has a unique solution, meaning that the determinant must not be 0, right? So 6s, 4, 3, 2s, x1, x2, right? 6, negative 2 here. So a determinant of a is what? 12s squared minus 12, right? So all we need to do is to make sure that this does not equal to 0. So that is s squared does not equal to 1. So you can see that s does not equal to negative 1, positive 1. So as long as s does not equal to negative 1 and positive 1, then it's all good to go, right? So it's all good to go. So all real numbers except negative 1, positive 1. Okay. So that is that is number there is number 6. Okay, cool. Let's continue. Asked to find the area of the parallelogram whose vertices are, negative 2, 0, 0, 3, 3, negative 1, 0, right? So as you can see, as long as you got two vectors, this thing is going to be perfectly fine. So this is vector u, this is vector v. So vector u, as you can see, it's going to be 2, 3, right? Vector v, well, it's going to be 1, 0. So 2, 3, 1, 0. The determinant a equals -3. So hence the area is going to be 3, right? Which is the absolute value of -3. So that part is easy. Find the volumes are parallelopiped with one vertex as origin and the other. So you see vector v1 is going to be 1, 0, -3, v2, so 1, 2, 4, v3 is going to be 5, 1, 0. So we know that the volume of this parallelopipe is going to be equals the absolute value of the determinant if you list them as columns. So it's -3, 1, 2, 4, 5, 1, 0, right? So we're looking for the determinant of those. And that is 1 times 2, 1, 4, 0. -3, right? So it's a 1, 5, 2, 1. So I'm going through the first column. It's 1 times -4, -3 times this is -9. So it's -4 plus 27, 23, right? So that's it. Okay, so I hope you enjoy this and have a good one. Thanks.